Hello and welcome to the second installment of talkTech with Beck. Today we're going to be talking about REST, what it is, where it came from, and why we like to use it. REST is an acronym for Representational State Transfer. It was defined by Roy Fielding in his dissertation for his PhD in Information and Computer Science from UC Irvine, titled Architectural Styles and the Design of Network-Based Software Architectures way back in 2000. If you want to read his thesis, I'll link it below. One thing he said about it while he was developing REST, working on his thesis, he said, and I quote, "Throughout the HTTP standardization process, I was called on to defend the design choices of the web. That process honed my model down to a core set of principles, properties, and constraints that are now called REST." What is REST? It's an architectural style for APIs that typically relies on HTTP protocol as well as JSON formatting to send and receive messages. It utilizes the CRUD and those verbs that we love like post, get, put, delete, patch. And it keeps API calls as simple as possible to understand. It is easy to learn. REST has 6 guiding principles or constraints that should be met in order to be considered RESTful. It has become popular because it is both simple to learn and use, and it is easily scalable. The 6 principles are: number 4, uniform interface. Number 1, client server. Number 2, stateless. Number 3, cacheable. Number 5, layered system. And number 6, code on demand. Now, this one, it's optional. Now, in Roy's thesis, he starts with client server and uniform interface is number 4. But I'm going to start with uniform interface because in my readings, without uniform interface, the architecture cannot be RESTful. But if you're missing or sort of fudging like one of the non-optional others, it can still be sort of REST, just like not truly RESTful. Kind of like a bad nap instead of like a good 8 hours. So let's talk uniform interface. So this one feels pretty self-explanatory as it is the central feature that distinguishes REST from other network-based styles. Basically, once you become familiar with one API in a RESTful project, you should be able to follow the same or similar approach for all the other APIs in that project. This includes ensuring that resources should only have one URI, and that is where you fetch all of your related data. Resources across the whole system should be following the same naming conventions, links, formats, and or data formats, like using XML or JSON for your database, though RESTful APIs typically use JSON because it's smaller and so faster. This also allows all resources to be similar accessible, like using HTTP GET. All right, so back to number 1, client server. Requiring a separation of client and server code allows your front and back end teams to work on their own parts without constantly running into issues. The ease of implementation also helps increase productivity. This basically means that your client side and your server side application will evolve separately without dependency on each other. With no dependency, how would your front end connect to your back end? Client side only knows the URIs where your back end lives, and that's it. So basically, client code becomes more portable since it's not dealing with data storage, and the server becomes more scalable since it is 0% concerned with user state or interfaces. This also means that servers and clients can be replaced and or developed independently as long as the interface between them is not altered. Next, we go to number 2, statelessness. So inspired by HTTP, which is also stateless, though not sessionless, REST reflects that inspiration by requiring statelessness, but unlike HTTP, it is also sessionless. The server does not store anything about the HTTP request made from the client side. Every request sent to the server is not only brand new, but it also must be complete. Now, this sounds like it may not be great if you have to log in and then do things that require that authentication, but that's not true. It is great. All it means is that each request from the client needs to contain all the information needed to complete the request, and that includes the authentication and authorization details from the client side. If your server had to store the session of every logged in user, then that data can start to take over and slow down your backend since it's using so many resources on the server. No one likes a slow website. We need our data now. So in keeping state and sessions out of your backend and only sending what's needed for each request back and forth, the server is only using memory when handling the client request. And then, as soon as it's done processing, that memory is available for another request. This is what Roy had to say about statelessness. Quote, "This constraint induces the properties of visibility, reliability, and scalability. Visibility is improved because a monitoring system does not have to look beyond a single request datum in order to determine the full nature of the request. Reliability is improved because it eases the task of recovering from partial failures. Scalability is improved because not having to store state between requests allows the server component to quickly free resources and further simplifies implementation because the server doesn't have to manage resource usage across requests." That's section 5.1.3 from his thesis, which, again, will be linked below. Next up is cacheable. Is it cacheable? What is cache? What is a browser cache? The definition of a browser cache from techterms.com is, here it goes, browser cache. Most web browsers cache web page data by default. For example, when you visit a web page, the browser may cache the HTML, images, and any CSS or JavaScript files referenced by the page. When you browse through other pages on the site that use the same images, CSS, or JavaScript, your browser will not have to re-download the files. Instead, the browser can simply load them from the cache, which is stored on your local hard drive. So, what does that mean in terms of REST? So, caching refers to storing the server's responses in the client so that the client does not have to make the same server request over and over. It's like the solution to issues with the server remaining stateless. So basically, the data within a server response to a client request must be implicitly or explicitly labeled as either cacheable or non-cacheable. Cacheable responses get cached on the client side, giving them the ability to reuse that data for later requests. This also helps avoid caching of old or inappropriate information. And number 5, we're going to talk about the layered system. So this is basically just allows you to use multiple servers. You can host your API on server A, store data over here on server B, and then send all of your authorization or authentication requests through server C. Typically, this is hierarchical and can keep separate components blind to layers that they aren't interacting with. Last but not least, we have code on demand, which is optional. Despite it being a principle or constraint, this one is not compulsory. Servers can temporarily extend or customize the functionality of a client by the transfer of executable code like JavaScript. From Roy's thesis, again, we have this quote: "REST allows client functionality to be extended by downloading and executing code in the form of applets or scripts. This simplifies clients by reducing the number of features required to be pre-implemented. Allowing features to be downloaded after deployment improves system extensibility. However, it also reduces visibility and thus is only an optional constraint within REST." That is from section 5.1.7, Code on Demand, from his thesis. All right, so those are the 6 guiding principles of REST. So why do we use it? What makes it advantageous over other APIs? Well, we use it because due to its flexibility, its speed, its popularity, and its scalability. So first, flexibility. Though it's most commonly used with HTTP and JSON, devs are able to use other data formats like XML or HTML or really whatever is best for them as long as it's uniform. Second, speed. They're just faster. Being stateless, using a client-server separation, layered systems, it just uses less overhead. While we may not typically notice the speed difference while we're surfing the net, as more and more requests are made, the speed difference starts to be noticeable. Popularity. Google, Twitter, YouTube, all RESTful APIs for users sending and receiving messages. According to Cloud Elements 2017 report, The State of API Integration, SOAP versus REST, Public APIs and More, REST dominates with 83% of APIs using it. And last, scalability. They're speedy, they're simple. So as you scale up, as you get more users, as your app grows, as your company grows, you're going to hit fewer speed bumps. You're always going to hit speed bumps because I'm learning that's just what computer programming is just bumps and puzzles. But this is going to be so much easier, and you're just going to scale up and grow and be the next Facebook or Twitter. It'll be great. Just use RESTful APIs. So that's it. I hope that helped you understand a little bit more about RESTful APIs, why and how we use them. I learned how to code in a boot camp just a few months ago and knew nothing about programming before starting up. So now I'm just bringing you information about things that I needed clarification on, as well as tips and tricks that helped me get through 15 weeks of full-time learning. So if you like what I'm doing, go ahead and give me a like and a subscribe down below, and stay tuned. I will be putting out something every week, maybe twice a week, as we continue to grow. Thanks for watching. All right, and 3, 2, 1, action. It's easy to learn. It's an architectural style for APIs that... This is what Roy had to say about... This is what Roy had to say about statelessness. This... All right, last but not least is cold on demand... Cold.